Yeah, I will get confused, guys, because I don't know who, to whom which batch I shared what. Okay,
Okay.
I will show you what are the documents. I have enough documents, even for CCNA, CCNP, VMware, even cybersecurity, enough document. But thing is, you have to study. That is main important.
Okay.
Material, don't bother about the material. So enough material, I got it. Okay, so let's start with today's session, guys. Today I'm going to discuss the your topics like we shall discuss. Let me write. We'll do the switching and we'll do the lab for your VLANs. Okay, then your inter VLAN. Okay, inter VLAN routing. So these two are both are labs, guys, which I'm going to discuss today now.
Mm-hmm.
Okay, so if you have the time, so we'll also try to do your with the two physical interface using the router or sub interfaces.
Okay.
Sub interfaces, and one more topic is trunking. Okay, so these are the topics which I'm going to discuss today.
Mm-hmm.
Okay, so right now we are discussing about your layer 2 switches, guys. Okay, layer 2 switches. So what is a switch? You can see the basic definition is switch break up the large collision domain into the smaller ones. It has a lot of ports, so each port is a domain. It's a collision domain by itself. Okay,
Mm-hmm.
uh, collision domain is a network segment with the two or more devices share the same bandwidth. Okay, so as you know, what is the job of the switch means? It will share the same bandwidth for your all end user devices. So it might be the hub. Okay, typically use most of the technologies. Now hub has been replaced now. So hub we are not using. So most of the organizations they have shifted to your switch guys. So each port on the switch actually it's a own collision domain. Guys, please remember this. This is a CCNA exam, guys.
Mm-hmm.
It's a CCNA exam question. What is what is its own collision domain? Means for the each port on your switch, it's a own collision domain. Means it divides the your bandwidth, it divides your network as well. Okay, so you can make much better Ethernet LAN networks just by replacing with hub to your switch. That's the reason switch is as most of the organization they use switch to connect your all wireless devices, wired devices, wipe. Okay, even servers connecting for your end user devices because of this more intelligent device, and it is quite very faster than router guys. Remember this part. It is a faster device than your router, and it has no on and off button. When you see any switches, especially most of Cisco switches, there's no on off button. Directly, if you just connect your power card, so automatically it'll on. There's no on off button. But for the router, it has router, firewall, and your wireless controller devices. They have the on and off button. Even for your wireless routers at your home also, I think you have the on and off button, right? For the
Yes.
switch, there is a no on and off button. Directly it'll on. The service for the switch is so unlike that use the software to create to manage the filtering table, switch use the application specific integrated circuit. Okay, so as you know that it is going to interact with applications where it user generate the data. So which will once the user send any data, so it will convert it into frames. Switch can understand only the frames. It doesn't understand the data. That's the reasons they are given the name application specific integrated circuit. Okay, so later switch and bridge are the faster than router because they don't have any uptime looking for the network layer for your header informations because it's not depending upon the other layers. Okay, it is an independent device. That's the reason it is quite very fast. They look at the frame hardware address before deciding whether to forward the frame or drop. Okay, so it will see the hardware address. So from where it has come, okay, whether you want to forward or drop your frames. And your layer 2 switch is so efficient that no modifications to the data packet take place. It doesn't do any modifications of your packets when the data has been come from your network layer. It doesn't do any modifications. Just it will read the MAC address. It will check to whom you want to communicate. The house switch and bridge learn the MAC addressing. Read the source MAC address of the each received frame and or datagram. Record the port on which the MAC address has been received. Say, this is my PC, so which I have connected here. Okay, so imagine this is my MAC address. Okay, with the interface faucet on 0/1/0. Okay, what it does in the MAC table, it will make an entry from which interface it has been come and MAC address. It will record it. Right. So even the best example I can see you guys, because at your home also. Okay. So when you connect your mobile phone or any laptop or desktop, okay, from DSCP you are getting one IP address, right? So when you disconnect and connect once again, so it will give the same IP address. It will not change the IP address. Did you notice, guys? Because of the MAC address, because this MAC address has issued this address, so it will issue the only those IP address. So in my laptop, okay, my Dell laptop, okay, so IP address which I issued my router is 0.26. Yesterday I showed you, right? Same thing today also. If I check, it will show you the same IP address. But you can change it. Doesn't it? We cannot change. We can change the IP address. No problem. But it should be the same network so that it can communicate to the internet. Okay, so these are the each what it does. I want to explain this slide here. So so Ethernet access switches where it will create a separate path in your bandwidth, so that each can understand. Okay, it will not club the data. In the sense, multiple devices can send at the same time. It has got capability. So now, if you talk about throughput, the port throughput will be depending upon your devices. Okay, maybe your L2 device or your end user device. Okay, suppose if you check, so I have my other laptop. The port it will support up to 100 Mbps. Okay, if you connect this port, the link speed is, suppose if you take 500 Mbps, and the port you have connected for 100 Mbps, it will show you within the 100, guys. Remember that. It will not show even the speed because the port throughput capacity is less. It will not show you that. So that's the reason yesterday I checked, I think I have showed you, right? I checked my internet speed. The reason why I showed you is just I want to show you the laptop which you are the entity laptop what they are given, the throughput of the port is very high. It will support about to 1 gig. So I have one more desktop, so it will not support 1 gig port. Okay, when you buy the devices, make sure you should check these parameters, hardware specifications. So when the throughput is good, okay, your traffic will route very fast, right? So now switch and bridge, how does it work? Because it learn your learning the address, forwarding and filtering decision it takes, and it also avoid the loop avoidance. Okay, that we should discuss, guys. Loop avoidance. What is the loop? It has got 3 features, guys. So unknown unicast also it supports, broadcast frame and multicast frame. Okay, so unknown unicast, because if any update has been come, even for the company also we are getting like unwanted mails, even a lot of securities. So even if you check, there's a lot of unnecessary mail like spam mails in Gmail for how they are getting. So they will send like bulks or tons of emails, unnecessary mails. And broadcast is required when you want to give the new update to your company. I think you might know if you open your Outlook, So even you don't know those people, you are getting some updates, right? Some mails
Yes.
from
Yes.
CEO, some these things, because they use this multicast and broadcast IP for every organization. Okay. So yesterday talking about the IP addressing, right? For every network, every subnet, they'll be having a multicast IP and broadcast IP. It's like this, guys, because I think you have the team, right? So in the teams, we'll be having a lot of people. They're using a lot of laptops and data. Okay, suppose I have the new update. Okay, I'm also belongs to the entity part. Okay, so I want to give the new update. So what I'm going to do? So I will give the update to the one of the guy. So he cannot update each and everything individually mail, right? What do we do? So this network is belongs to, say example, this is 192.168.1.0/27, means it is subnetted. The main network is 192.168.1.0/24. Slash 27 indicate that it has been subnetted. So it used that multicast IP, that is 192.168, I think 1.32. I'm correct, guys? It
Yes.
used this IP address to update to all, automatically send the mail to all. No need to send individually. So even the, I think I showed you, right? Like I think our CEO, Dubai, Mr. Dubai, I think you have seen. So we have got some updates, some changes, some every quarter, what is the business has been generated by entity every 6 months. Okay. So they will not send by individually employees because a lot of employees throughout the world for entity. So this
Yes.
is the one which, how does it works? So let's talk about how the switch will learn the MAC address. Now it is empty, right? You can see the MAC address is you are empty now. You can see now it is empty. So just understand this here. If the station A sends to the station C, okay, this guy sends the frames to station C. So first time switch, what it does, it broadcasts to all, correct?
Mm-hmm.
Okay, it broadcasts to all. So once this has been sent, so MAC address, what it does, it read the MAC address, sorry, interface name and MAC address of that PC. Okay, it has learned from this interface and MAC address is this. It will make an entry. Okay, so then switch cache the MAC address to the station bit for the port by learning the source of the data frame. But frame from the station A to C is flooded out to all the port except the port himself. Not only for this, it will send to all because these people will not accept because this guy want to communicate with only your station C. So now what happened next time? So next time now station D want to communicate, want to send the frames to station C. Means this guy want to send to your station C. What it does, again switch, it will broadcast to all the guys. Now switch will run, will learn this, it will make an entry with this guy and its MAC address in his table. Okay. So next time what happened? Station A sends the frames to station C. Now what happened? Now this guy want to communicate with C. What will do? Anybody can explain? What will
Destination MAC should be updated.
destination?
MAC should be updated.
It is updated already. See, if you check the previous slides, okay, the first slide what is talking about. So when PCA send the frame to PCC, it will make an entry, right? With
Yes.
with PCA. In second scenario, if D guy want to communicate with D guy want to communicate with C, so we can see it will make an entry with this interface E3 and it will make an entry.
Mm-hmm.
Now next time when again you want to communicate with station C, it doesn't do the broadcasting. It will check before broadcasting whether this guy is available in my routing table. Is available, right?
Yes.
Then it will send directly to the station C. it doesn't do the broadcasting. This is called filtering the frames. Understood, guys?
Yes.
Because
Yes.
Yes.
because destination is known now. We know the destination. Frame is not flooded throughout the network, because flooding the throughout the network means it's consumes the bandwidth, and your switch will become very busy. It will make a lot of noise. So I don't know how many people have seen the rack. Okay, if the transaction, the termination is quite very fast, the traffic is going around on in the network. Okay, the device will make a lot of noise. Same thing, broadcast and multicasting. If the station is in the broadcast or multicast frame, so what it does, so it broadcasts to all, because this is your broadcast and multicast frame. Because he want to give any updates, new updates. Say example, we can see like CC is this thing. If you send, it will send to all, right? And there will be separate this thing in your applications are there where you can send all multicasting. Okay, so what is forwarding and decisions? Okay, so when a frame arrives to the switch interface, destination hardware is compared with the forwarding and filtering of the MAC database. So whenever the frames comes, it will check whether this frame, this MAC address exists in my MAC table. So if it is exists means, then it will forward directly to the specific guy. It will not do the broadcasting.
Broadcasting.
Doesn't do the broadcasting. If the destination hardware is known, the list of database in the frame send out only to the correct exit interface. Correct? Only to the specific guy it will send. So if the destination hardware address is not listed, okay, in the MAC database, then the frame flooded to all the active interface except it has been received. If it is not available in the MAC table, what will do? It will broadcast. If the host or server send the broadcast to the LAN, the switch flood frame out all the active port except the port itself, except the source port. Except for him, it will broadcast to all, whether it is received from your PC or from the server. So here is talking about how the MAC address will be learned. So we can see, so this is the MAC address. This guy has sent some frame with this interface. Okay, it will make an entry. Okay, address and interface name. Okay, then it will forward to this guy. And this guy, what he does, so this guy also will make an entry. So with the 33 MAC address with the interface name /24, because it has this switch has learned from this interface, right? Now PC1 send the frames with this MAC address, so it has learned with 11, so it will make an entry. Again, it will forward to this switch, okay, and this switch also will add the MAC address. You can see here, it will MAC address with the same port because it has learned from this port. What if you connect PC2 here with this MAC address? Okay, it will send to this one. It will make an entry here. Okay, it will send to this guy now. So this guy, what it does, it will make an entry here. Entry, but this guy has learned the MAC address with this interface /23 with this interface. Understood, guys? Okay.
Yes.
Okay. Now what happened? Now destination is 1.1 means this guy. Okay, this guy want to communicate with this guy. So what we'll do before sending to all, it will check. Okay, I know it is there in my MAC database. So directly it will send. It will not send to this guy. Not send. And same thing for destination 22 means this guy want to communicate with this guy. And this time he will not communicate this one because he want to communicate only with this guy. So what is a loop, guys? And this is the important topic from here. So we'll take another 30 minutes. Then we'll take small break. Then we'll jump for the lab now. Okay. So as you know that in any network, guys, a redundancy link is very important for the switching. Is a good idea, right? Because they help you prevent your complete network failure if one link stop working. Correct? You know about redundancy, right? Redundant. Satya, what
Yes,
is
sir.
redundancy? Redundancy means what?
Because I don't know.
I guess redundancy means that it is uh, it is present at the larger scale, but it is not needed at that larger scale.
Mhm. Okay, fair enough. Any other guys?
If in case any links go down, like it might have like multiple links to connect.
Alternative
Yes,
path.
Like a backup purpose.
yes, yes. Redundancy. If one links go on, suppose these are two links are connected. One links go down, so your traffic will be routed to this.
Mm.
Okay. Same thing. Suppose for any organizations, they will take two or three lease line internet connections because anytime the line will go down. That's the reason they route with the one links go down, it will go to other link. Okay. Now, so here what I'm talking about. So redundancy is very important in the network. Okay. Here in this scenario, redundancy is creating the issue here. Okay, let's discuss this network broadcasting loop. So what happened here? A manufacturer flooding the PCs send the network to broadcast. So I don't want to read out this. So what happened here? When this manufacturer send any data, what happened? It will send to this side, also this side. Correct? When this switch receives the data or frame, okay, what it does? It will send to this guy as well as this guy. So what this switch will think, okay, so I have got the new frame, so I will forward to this guy as well as this guy. Okay, now what happened now? So each one is sending to each other. What happened? It became a loop, right?
Yes.
It became a loop now.
Mhm.
Yes.
Of course, at this topology, it has got the redundancy, right? It has got redundancy link because if these links go down, so still I can able to communicate with this. The problem here is, so it's creating a loop here, correct?
Yeah.
Yes.
Yeah.
Okay. So for that, the solution they have come up with, that is your STP. That is your spanning tree protocol.
Because
Okay. They have come solution because suppose if you talk about this thing, when that data is coming this side, again to send, they will think that it's a new frame. It has come to me. I need to send to forward. It does. Even switch also does the job. Hub also. It
Mhm.
forward it. Whenever it think there is a new one. I need to forward it. He'll forward it. Again, it will come back. Again, he will think it is a new one. Again, it will forward. Then it will become the looping. Okay. To avoid that one, so your solution is your spanning tree protocol. We shall discuss now. So what happened here? If you have like this one, so multiple frame copy will be generated. We can see the unicast here also receive, this guy also receive, this guy also receive in the one network. So what happened? The multiple copy, the frame broadcasting is looping in the network. Your bandwidth will consumes, your hardware resource of the devices will increase, and your network performance will completely will go down. Okay, so being a good network engineer, so make sure that your uh, uh, properly utilization of the bandwidth is very important for any network engineer because as you know that bandwidth is not a free of cost. Correct?
Mhm.
Right. Bandwidth is not a free of cost because you have to utilize proper bandwidth. Unnecessary broadcast, unnecessary unicast, multicast message should be dropped. Okay.
Yeah.
So the solution is your spanning tree protocol. That is STP. Okay. So as you know that, so redundancy in the network is extremely important because the redundancy allows the networks to the your fault tolerance. So redundant topology based on the switch and bridge subject to the broadcast storm, multicast storm, transmission, these things. So let me explain this very simple way, guys, because you explain a lot of things here. So I have to explain very simple way. So what happens, guys, here? The basic, I'll tell you the basic function of the spanning tree protocol. So spanning tree protocol, you know that. So when you connect the two switches, the two links, so by default, any one of the links is going to block it by default. That is a basic characteristic of your spanning tree protocol. Because to avoid the loop, to avoid the duplicate frames in the network. Clear, guys?
Mhm.
Clear. So as we can see in the diagram, okay, so by default is going to block it. And this lab will do, okay, will do today itself. Your spanning tree, VLANs, trunking, all the lab will do now. Okay, so what it does means is going to block any one of the port, any one of the link is going to block because to avoid the duplicate frame in the network. Is it clear now? Okay.
Yes.
So now, so we are started. Remember, guys, this is your CCNA exam questions. Spanning tree work on your layer 2. That is your data link layer. Remember this.
Okay.
Okay. So Ethernet bridge and switch are implemented in your IEEE. So 802.1d. Okay, it uses spanning tree algorithm to construct the loop-free network. So inside is an inbuilt algorithm will be running. So whenever the duplicate broadcast, unicast, multicast message is repeating, is going to block it. Okay.
Yeah.
So now, spanning tree port states. This is very important, guys. So I will be asking the question at the middle. At any moment, I'll ask the question. This is very important to understand. Even in the exam also. So most of the CCN exam I've seen. So this exam will ask. Even CCNP also they will ask. Okay, let's understand this. So let's understand what is BPDU, guys. It's talking about loss of BPDU. Any idea about BPDU? So bridge protocol
Data
data
unit.
unit. Good. So every 2 seconds, guys, every 2 seconds, okay, your switch is going to send the BPDU message to another switch to check whether the neighbor switch which is connected to that switch, whether it is alive or not. You know, so when the two switches are connected, okay, this is my switch 1 and this is my switch 2. Okay, by default, what does spanning tree does is going to block any one of the port, right?
Mhm.
So now what happens when, as just now I told, okay, this is active link. So it send the BPDU message every 2 seconds to check whether this guy, this driver is alive or not.
Mhm.
Right. Okay, now what happens? So in BPDU, it contains your bridge ID. For all the bridge ID by default, priority is your 32,768 for all Cisco switches by default. 768 with the MAC address. So now when BPDU, if this guy is down, if this port is down, okay, he'll not respond back, right? If this port is down or this link is down, okay, so within 2 seconds is not getting reply means this indicates that so this guy has done is down now. So it waits for 20 seconds. Okay, it get detected, it wait for 20 seconds. Maximum age is it wait for 20 seconds. Then what happened? So it listening. It's trying to make this guy up now. Now this guy is down. So to come up this link, so it takes 15 seconds for listening. Okay, and learning, it will take another 15 seconds. Then it will become forward. So how much time it takes? 20, 15, and 15. How much?
50 seconds.
15 seconds, right? 50 seconds. It takes 50 seconds to come up with this link. So this lab will do it now. Very simple. Connect two switches, connect the two links. By default, automatically we should not do anything. So any one of the link is going to block it. Okay. So it takes 50 seconds, right? Almost 1 minute, right?
Yes.
So in any production network, 50 seconds is not acceptable, guys. Means 50 seconds, there is a no communications in that organization, right?
Yes.
Just imagine if your customer is in the banking.
Okay.
What happened if the 50 seconds come down? In 50 seconds, at the same time, okay, the 50 seconds, some 100 crores online transaction has been made. Okay, transaction has been made. Is lost to the bank, right?
Yes.
I think they'll charge, right? For if you transfer 10,000, if you transfer money to my account, suppose like Vikas or like Satya has sent money to my account, they'll charge banking, right? Because HDFC Bank or Axis Bank or SBI Bank,
Yes.
3 rupees, 5 rupees, depending upon your amount size.
Yes.
Okay, that will be lost to the bank, right?
Yes. Yes.
Okay, so this is called your service level agreement. You'll be having that. So make sure that even zero time down, your links will never go down. That is the job of your being a good network engineer. For the solution for this one is, so they have come up with, that is your PVST, RSTP, okay, so and MST. So per VLAN spanning tree protocol, rapid spanning tree protocol, this all the lab part. So that we shall discuss in coming training, guys. Is it clear, guys? First understand. So these are the port
Yes.
states for the spanning tree protocol. So it takes 50 seconds to come up. Okay, because once if you're not receiving any BPD message, so for example, as simple as this, guys. So I think you might see in your schools, if one guy is sleeping, okay, any school children, okay, teacher is asking like to wake up means he'll wake up, right? He's not responding means that indicates that he's sleeping. He is also sleeping. So means the teacher will wait up to 50 seconds. If 50 seconds is not replying means he thinks that he slept completely. He's not listening.
Battery down.
But in the network perspective, 50 seconds is a big time. Okay, so down in PVST, especially RSTP, there it is reduced to 30 seconds.
Yeah.
Now on, we shall discuss in coming session now. So now we'll discuss about the how switch will become your root bridge and non-root bridge. The decision that switch will in the network make to identify the root bridge. So what is the root bridge? Means the team leader in the switch, guys. If you have a lot of switches, so any one switch should be the team leader. The team leader here will call root bridge.
Okay.
Okay. When switch is on, spanning tree algorithm are used to identify the root bridge. BPD was sent out to all the bridge IDs. Okay. What is a bridge ID? So bridge ID is nothing but this value. For all the CISCO switches, so bridge ID are same. And based on your MAC address. So who will become the team leader now? Any team lead here in this group, guys? all are team lead now.
Sir.
Who?
Divya Bharati.
Okay, Divagati, team lead. Okay. So here the selection of the team lead guys here. Here we'll call the root bridge. So how this election will be done here? So we can see when the switch start up, it assumes that the root switch and sending the BPDU. The BPDU is contain your bridge ID. Bridge ID is this. So what happened if you connect 6 switches together? If you on all the switch, they will think that I am the root bridge. I am the team lead. Okay, because why? Because if you connect the same Cisco switches together, they will your priority is same, right? They will think I am the root bridge. They will think I am the root bridge. Okay, now the second priority, what will check? It will check the MAC address. The lowest MAC, I think highest MAC will become your root bridge. Okay, so all the bridge decide your bridge with the smallest, your smaller bridge ID value with the root bridge. Or this is the one more option. Other option is we can reduce this value by 4096. Okay, suppose if you got switches connected, a lot of switches are connected with each other. We connect with each other, so they will think I'm the root bridge. So all the priority are same, right? For the all this priority are same. Yes. Now what happened? So if you reduce the value, you want to make this is a 1, this is 2 and 3. You want to make this guy as a root bridge. What you do? Just reduce the value with 4096 because lowest will become your root bridge. Okay. Now, I hope it's clear how the election process will be done by the root bridge, because I'll tell you why they are doing this one, root bridge. Same thing, how we are team lead, because if you want all the employees any update you want, so only the team lead can give the update, right? Yes. Only team lead can give any update, because from where our team lead will getting the updates from their respective clients. The client is required this one, so he or she will update to your members. Yes. Okay. The BPDU guys, the bridge protocol data units, exchange informations, okay, to select your root switches. By default, as I told, it has got 32,768 by default for all the Cisco switches, and based on your MAC address. The root bridge is the lowest bridge priority became your root bridge in the network. Non-root bridge, which are not belongs to which is got the highest one, they will become your non-root bridge. Means they are not supposed to give any update. Only the root bridge can give the updates, like your team leads. The root port. Okay, the root port is one always link directly connected to the root bridge or the smallest part to the root bridge. If more than one link connected to the root bridge, then the port cost is determined. So what is talking about, guys? So here is talking about if the root port is connected directly to the root bridge, okay, with the shortest path. If more links are connected to the root bridge, okay, then it will check the port cost. The port cost is depending upon your switch and your end user port throughput, how much it has got. Data can be transferred. That is your MTU. I think you know, right? You know MTU, right? Maximum transmission unit. Yeah, maximum depending upon throughput, because so in my laptop, one laptop has got 100 Mbps. Not it doesn't cross 100 Mbps. Only 100 Mbps by one port, Ethernet port. So in this entity laptop, what I got, so it has 1000 Mbps. Right, depending upon that. So now also depending upon your link, what kind of cable you are going to connect it. You are going to connect your CAT cable or your optical fiber cable. Okay, Here, lowest cost is the best. So now designated port is one that determines having the best lowest cost. Okay, so let me explain these guys. So let me open whiteboard. So let me open. So just imagine. So I have connected one of the switch here. So if you connect these two switches together, so as you know that, okay, your BPDU, okay, for default, your priority is 32,768, right?
Yeah,
32,768.
Yes.
768. So what happened? They will think that when you on these devices, they will think that I am the root bridge, I am the team lead because of their priority. Right. So what again? The second things they will check based on your MAC. So as you know that for every device there is a MAC. Right. They will be having the MAC. Okay. Who has got the highest MAC? Those guys. Suppose example, this is GIA, and this guy is B, and this guy is C. And who will become now? So obviously, so this guy will become your root bridge, right? I don't know which is the highest, A, B, C, D. The guy taken the C is the highest here. And this guy will become your root bridge. Okay.
Okay.
So now you don't want like this. I want this switch one, I want to make it as your root bridge.
Okay.
So how we can do? By reducing the value for this one, 4096. So this guy will become your root bridge. Okay. So now, again, he's talking about the root port. Right. The root port is the one which root port and designated port, okay, which is connected directly to your root bridge switch. This switch. Only this port can forward the new updates. So these ports only they can forward the new updates whenever you got any updates from your client or your customer. Okay, because this switch is your team lead, right? This switch is your TL, right? So only this switch can update to your other switch. These people cannot give any update even though they have received the new update. They cannot share it. Okay. So now he's talking about the cost. So as I told you that lowest cost is the best. So lowest cost is the best. Example, if I take, so, and this is my cost is 10, and this is cost is 18, and this cost is 4. So which will be the best path here? The spanning tree select the path now.
4.
4. 4.
For it because of the lowest cost. Because this port will become your designated port. Understood, guys? He'll not forward here. Only this guy will send. Even though you want to receive directly connected, he'll not receive from this port. Only he will receive this guy. Again, he'll send to this. Again, he'll receive from here. He'll not receive from here. Why you are doing like this means why we are so complicated? Because to avoid the looping, to make sure that the proper use of your bandwidths, okay, and your proper use of your hardware resource of the devices. Otherwise, what happened if you're not done any election process? Okay, just imagine. Okay, forgot about the example. So in your team, I think Vidya Bharati, if all your team members, if you make team lead, what happened? No one is going to listen each other, right?
Yes, sir. Yes.
Yes.
Okay.
Everyone are boss.
Becomes a fish market.
Yeah, no one is going to listen. I am also team lead. Why I should listen to you, right? Because what happened? The teamwork will come down, right?
Yes.
The performance will come down, right? And even the this one. So
Quality
nobody is going to do
controls.
that, right? Because everybody became team lead. It's difficult for them to work, right?
Yes.
Same thing here. So same thing here also. I think I opened two. So I close it. You want me to share this, right? I think yesterday I shared you,
Yes.
right? Yes.
This one, that compressed file you have shared yesterday.
Yeah.
Yes.
I think I remember yesterday. I think I shared it.
Yes.
Yeah.
Let me
Okay.
check it
So we'll do one
once.
thing, guys. So let me open this. And it will get some time errors, guys. It will open because since 10 years I'm using the same slide for CCNA, guys.
Mhm.
I have not done any changes. If you check my YouTube channel, also is there. There also you can see a lot of same slide I'm using. Okay, let me discuss this very helpful information. Before I could, guys, can you tell me who is the root bridge here? Let me ask you this one slide. Then we'll jump for the lab. Tell me, guys, who is the root bridge here?
Uh,
Second one.
why?
Second one. Why?
Switch
Why?
why?
Why, right?
Yes.
Yeah.
Yes, why?
So
Yes,
just
highest
remember,
why.
guys. So here, guys, please remember for spanning tree operations, one root bridge per network. For any network, they must have one root bridge. Okay. For one root bridge, they must have one non-root bridge. For one designated port per segment, for non-designated port are unused. We are not using for any non-designated ports. So usually non-designated port will be by default is your spanning tree is going to block it. It work as your redundancy link. Okay, guys. So please remember this point, guys. So what I mentioned here. So if you see uh, for 10 gig speed, the cost is 2. For 1 gig, cost is 4. And this is the old one. For 100 Mbps, 19. For 10 Mbps is 100. As you know, lowest cost is the best.
Okay.
Okay, just remember this. So let me go for some configuration part. Then we'll jump to the you can see the slide which I shared to you guys. So it has the commands, the basic command which I didn't explain: show version, show running, show interface, show interface status, show controller, show post. So these all commands. So just go through it. Okay. So not in that you can set the password and name and IP address for the subnetting for the VLAN interface. Okay, we can create SVI switch for virtual interface. We can give the IP address for the only for the VLANs, not for your ports. Just remember, guys, you cannot give the for IP address for your layer 2 switches. Okay. So what we'll do, guys? So we'll take one small 10 minutes break. Then we'll start with
Before
your
before we
yeah
take a break, Taj, I have one question.
yeah
For this bridge ID, the ID, the standard ID which you give, like 32768,
yeah
right? So why is it given as a 32768? And also, when you said that to make a root bridge, you have to reduce to 4096. Like, why? What is this number signifies? Why to that value itself?
yeah. See, because it is your this one standard numbers. So
Mm-hmm.
1024 is 1K, right?
Mm-hmm.
1024. So 1024, how much?
Uh,
I think
two,
1048.
2048.
48.
48.
2048 and
Yes.
2048, how much?
4096.
4096.
Okay.
right? 4096
Yes.
means, so as per the techniques, as per the technology, what they are designed it, okay, default 72,768 is a value, means 32K. But default switch they are given the priority because so that for their Cisco customers, they can customize as per their requirement. They want to select whichever the root bridge they want, okay, by changing the values. So not only 406, even like by default, like minimum 4096. Okay,
So
there is another way of doing the configuration. That lab we are doing now.
okay.
After this, we are doing the lab now. Okay,
Okay. Sure.
so we'll take small break, guys. So after break, 10 minutes break, we'll come back. We'll do the lab.
Okay.